All right, so today we're going to start our next chapter, which is talking about polynomials. And today we're going to be focusing on how to write them in descending order, and which creates standard form, and then also talking about the degree of a polynomial. So let's go ahead and warm up today with this do now and simplifying like terms, because combining and writing in polynomials in standard form is really similar to combining like terms and simplifying that process. So think about who gets to go first and what's the same. So if I take a look at this problem, I see that I have a 2x plus a negative 8x, that's a negative 6x. And then I see I have a positive 6, a negative 3, and a positive 8. So I am going to combine those. So 6 plus negative 3 is 3. 3 plus 8 is 11. That's a positive 11. And the only thing that I haven't used is my positive 2y. So I'm going to go ahead and drop that down. So I've now combined everything together. But now I have to think about who gets to go first. Okay? Who gets to go first? So remember that we go in alphabetical order by power. Okay, we go alphabetical by power. So that means x's go before y's and x squareds go before x's. So the bigger the power, it gets to go first. Okay, so if I take a look at this, I see that my y is technically out of place. So negative 6x plus 2y plus 11, that would be standard form. Okay, let's keep going here. Okay, so when we're talking about a polynomial, we need to know what a monomial is. A monomial is a number, a variable, or a product of a number or one or more variables. So product means multiplication, okay? So let's take a look at these examples. So it says negative 5 is a monomial. That's true because it is a number. P plus Q. It says no, it is not. Well, it's not because it's adding. That would be a sum. It didn't say sum up here, it said product. And x is also a monomial because single variables are monomials. All right, let's decide on these bottom ones if they're monomials or not. So let's look at the first one. Negative x plus 5. Yeah, this one is not a monomial because it is adding. Okay, it is adding. What about the next one? 23abcd squared. Looks like there's a lot of variables, but is it a number, a variable, or a product of a number or one or more variables? Well, this happens to be a product. It's not adding, it's not subtracting. So this one is a monomial. Doesn't make any difference how many variables are in there and how many of them have powers. All that matters is that it's a product. Okay, now we're looking at two division problems. One of these is a monomial and the other one isn't. Okay, this one is the monomial. This one is not a monomial. And the reason why is because the variable cannot be in the denominator. Okay, no variables in the bottom of a fraction because that makes it division. This one is actually 1/2 times, which is a product. Okay, so we have to be able to identify those differences. All right, so then we're also talking about some more vocabulary. Since the first day of the chapter, there's lots of vocabulary. So terms are how many monomials are in the polynomial. So for example, if I gave you 3x plus 2, that's 2 terms. If I give you 5x plus 4y plus 8, that's 3 terms. Okay, 1, 2, 3. How many different things or different monomials are in the polynomial? Now, a polynomial is just is any group of monomials or of sum of monomials. So if you think about this in terms of like dessert, if I think about the word dessert, that means I'm talking about cakes, pies, candies, all sorts of things, cookies, pudding, all those things. So polynomial is like the big overreaching definition, okay? And inside of there's monomials that mean 1. There's a binomial that means 2, like a bicycle. So 2x plus y, that would be a binomial because there's 2 terms. And then we have a trinomial, which would be 3 terms. So 3x squared plus 4x plus 3. That would be a trinomial, okay? That would be a trinomial. And there's some examples down here at the bottom. All right, so let's decide what types of monomials and polynomials these are. Well, there's one term, so that one's a monomial. What about this one? There's two terms. That would be a binomial. How about this one? There's four. Well, but I see that there's these like terms here. So those two, if I put those together, that would be negative 3y squared plus 2y minus 1. So now it's a trinomial. Okay, now it's a trinomial. What about this one? What do you remember about a negative power? Yeah, that puts it in the denominator. That's really 10 over x to the fourth minus 8x3. Is that even a monomial? No, so this is nothing, okay? That isn't even a polynomial because I can't have variables in the denominator. No variables in the denominator. All right, so we're going to write a polynomial to represent the area of the shaded region. So let's think real quick about area. So if this is a rectangle, that's 4 by 5. The area is 4 times 5, which would be 20. So if I look at this, I actually have the big triangle or the big rectangle that's shaded, and then I have the small rectangle that is open. So to find the area, I would need to take the area of the big one minus the area of the small one. So my big one is 4x times 2x. So 4x times 2x. Well, that's going to go back to my variables or my exponent rules. So 4 times 2 is 8, and there's 2x's, that would be x squared, 8x squared. Now my small one would be 2x times 1x. That's a coefficient of 1. So 2 times 1 is 2, and I again have 2 x's. So 8x squared minus 2x squared. Is that finished? Or can I simplify more? Yeah, I can simplify more. 8 minus 2 is 6. Notice that my x squared didn't change. Remember, if I take a group of Red Delicious apples and I take away some of the Red Delicious apples, it didn't change all of a sudden to oranges. They are still the same thing, okay? So when I add and subtract, we are not going to change the power. You are changing the coefficient. All right, so when we're talking about the degree of a monomial versus the degree of a polynomial, okay? The degree of the monomial is the sum of the exponents of all the variables. The sum of the exponents of all the variables. The degree of a polynomial is the greatest degree of each of the terms, okay? That's completely different. So let's take a look at the degree of a monomial. This one, I have a variable of y has a power of 4, so the degree is a 4. The variable has a power of 1. Its degree is 1. Notice I'm not paying any attention to the coefficient. The coefficient does not matter. All right, let's look at this next one. I'm going to write this next one out. 2x y squared z3. Remember, I'm looking at the sum of the exponents. So what power is on the x? Yeah, it's a 1. And I don't care about the 2. Don't care. That is a coefficient. I need only the exponents on the variables. So 1 plus 2 plus 3. That would be a degree of 6. Okay? Now, if I give you a 7, that's a degree of 0 because there's no variables. There's no variables. All right, now, when we go to a polynomial, things change. We look at the degree of each term and figure out which one is the biggest. So if I have 5mn squared, well, I know that's a 1. So 1 plus 2 gives me a 3. So then that's done. It's a 3. This next one, I have 1, 2, 3 terms. Well, this 5 has a degree of 0. So that one is done. Okay? The next one has a power of 2, so that's the only power that's there is 2. The next one has a 2 and a 2, so that's a power of 4. Which of those is the biggest? The 4. So the degree of that polynomial is the 4. I don't add those. It's just the biggest, okay? Okay, let's do a few of these together. Oops, lost my right slide here. All right. Here's a monomial. Remember, I'm looking only at the variables. I'm going to cross out my number. The x has a power of 1. The y has a power of 5. The z has a power of 1. So the degree would be 1 plus 5 plus 1, which would be a degree of 7. Okay, this is a polynomial. So we're going to look at each term. So this one has a 3 and a 2, so that's a degree of 5. This one has a 1 and a 2, that's a degree of 3. Well, this one doesn't have any variables, that's a degree of 0. Who's the biggest? Yeah, the 5. So that one has a degree of 5. Remember, I'm looking for the greatest number, okay? The biggest number when I'm looking at the degree. All right, hit pause, see if you can figure out this next one. All right, let's see how you did. Okay, cross the 2 out. 1 and 1 is 2. Cross the 3 out. The r is a power of 1. 1 plus 2 is 3. Cross out the 7. 2 plus 2 is 4. And there's no variables. That's a degree of 0. So looking at this one, what's the biggest number? The 4. So the degree is a 4. All right, now let's talk about writing things in descending order. Okay, descending order. And normally when we write them in descending order, which means big to small. Okay, the biggest power to the smallest power. So if I take a look at this problem right here, you can see I have a power of 2, I have a number, I have a power of 1, and a power of 3. So who's the biggest power? It's the 3, so that one would get to go first. Okay, so I've used that one. The next one is the 2. That one gets to go next. And then I'm looking at the 8x and the 5, so the 8x would get to go first. Okay? Now this one has multiple letters, but I'm only looking at the x. So this one has a power of 2. This one doesn't have any x's. That has a power of 5 and a power of 1. So if I have a 2, nothing, a 5, and a 1, who gets to go first? Yeah, the 5. So 4ax5 would be the first one. So I've used that one. So now I've got a 2, nothing, and a 1. Who's next? Yeah, the 2. So then that one would come next. And then I use my power of 1, and then my 1 that doesn't have any x's. That is descending order according to my x's. Okay, so go ahead and see what you can do on these problems. See if you can write them in descending order according to your x's. Okay, according to your x's. All right, let's see how we did. So this one is an x squared, that one's an x cubed, that one doesn't have any x's, and that's a power of 1. So the first one would be 2x cubed y. I'm going to cross that one out. All right, who's next? Well, I see that that is a 4x squared. I know that's positive, so positive 4x squared. Who's next, the 5 or the negative x? Yeah, the negative x, because x's come before numbers. So 2x3y plus 4x squared minus x plus 5, that is done. Okay, again, x's. There's a 1, a 7, a 4, a 2, and nothing. So the first one is going to be my 7. So 2x7y, cross it out. Now I've got a 1, a 4, and a 2. The 4 is going to go to the next. So negative 5, x4y8. And then I'm going to go with my x squared. Then my x, and then my 3 is finally last. Okay, we're back to x's. I have a 3, a 2, a 5, and nothing. So the 5 is going to go first. It doesn't even matter if there's extra variables in there. Which one's next? The 3, negative 7, a squared x cubed. Who's next from there? The positive 4x squared. And who's last? You're right, the positive 2a. And this last one, remember, I'm going in order of alphabet, okay? So it's alphabetical by power, so we have a couple issues here, okay? Couple issues, and we're still going by x. So we're still going to start with this guy, negative 2ax5. Oops, I got too many a's in there. Let me start over with that. Negative 2ax5, so that one's gone. And then I have an x3. And then I have a 4x squared. Okay, so now I'm left with y's and an a. Well, it's alphabetical by power. So if I'm going by x's, it's kind of a toss-up, but I know that that one has a power. So that is going to go before anything that is single, okay? That's going to go before anything that is single. Now, if I am just writing in standard form and I don't have powers, then I'm going to make sure that my alphabet is following. All right, so here's kind of another example for you to look at when I'm combining like terms. You can see that I have a negative 10 AB squared and a negative AB squared. Those are actually like terms. If I combine those, that's going to be a negative 11. Okay, so the same thing goes with my 2a cubed and my 3a cubed. Those are like terms. 2 plus 3 is 5. Notice that the variable and the power does not change when I add. Only the coefficient, okay? Only the coefficient changes when I'm combining like terms. All right, so let's see if we can add these polynomials. And I'm going to show you two methods. I'm going to show you a vertical method and I'm going to show you a horizontal method. It doesn't make any difference to me which way you do it as long as you can get there, okay? So if I look at my vertical method, I'm going to start by writing 3x squared minus 4x plus 8. And then I'm going to take my second equation and I'm going to write the like term underneath where it goes. So the 2x would go underneath the 4x. The negative 7x squared would go under the 3, and the negative 5 would go under the 8. And then I'm just going to add down. 3 minus 7 is negative 4. Negative 4 plus 2, that's a negative 2. And 8 minus 5, that's a positive 3. So this is done. Negative 4x squared minus 2x plus 3. It is in standard form in descending order, and I'm done. Okay, if I want to do horizontal, when I look at horizontal, I'm just going to use my problem up here. I tend to circle the like terms. So 3x squared, and that's, keep the sign with us, that's a negative 7. So 3 plus a negative 7, that's going to give me a negative 4x squared, okay? Then I'm going to go to the next one. I'm going to use a box. Negative 4x, and that's a 2x. So negative 4 plus 2, that's a negative 2x. And what haven't I used? I haven't used the 8, and I haven't used the negative 5. So 8 plus negative 5 would give me a positive 3. So you can see either way, I get exactly the same answer. Okay, how am I going to simplify this expression? Well, I think the first thing that I should see is I see there's this minus 1 there. And I know that if I have a number outside the parentheses, that is a distributive property. So I'm going to go ahead and distribute and rewrite this problem. So negative 1 times 2, that's a negative 2x. Negative 1 times negative 6 is a positive 6. And a negative 1 times 5 is a negative 5. So now I don't have any parentheses left, and I can combine like terms. So what things are the same? Well, I see that there's a negative 2x and a negative 5x. Let's add those. Negative 2 plus negative 5, that's a negative 7. What's left? I have a 5 and a 6. 5 plus 6, that's 11. So there's my simplified answer, negative 7x plus 11. Remember, standard form, x's come first. All right. Let's go ahead and distribute these and combine like terms and see if we can get them right. Go ahead and hit pause. See if you can get them. I'll catch up with you in just a minute or two. All right, let's see how we did. So the first thing I'm going to do is distribute. So negative is a positive, and a negative and a positive, that's a 1, and I got to make that a negative 1. So negative 1x squared, and a negative 1 times 2, remember that's a negative 1, is a positive 2. And I'm going to go ahead and do vertical on this one, just because I can. So the 4x cubed, I'm going to write underneath of this one, cross it out. Negative 3x squared, that one goes here. A 6x. Well, I don't have a 6x in there, so I think I'm going to write it over here, and then I'll worry about putting things in order. And then my minus 4 goes underneath my 2. All right, so finishing this up, I'm going to add down. 4 plus 2 is 6. 6x cubed. Notice the coefficient changes, the power doesn't. Negative 1 plus negative 3, that's a negative 4x squared. And I know that my x has to come next, so I'm going to go ahead and put my 6x right in here. And then positive 2, negative 4, That's a -2. So I'm done. I am done. All right, let's see how you did on the next one. So I see that this one and this one are like terms, and I am adding, so I don't have to distribute anything. I can just forget that the parentheses are there. 8 plus 2 gives me 10 CD. Now, are there any more Ds? No, so this needs to drop, and the 4C needs to drop, and so does the -6. All right, now, that's a lot of letters. Who gets to go first? Well, it's alphabetical. So the first letter in the alphabet with the C's and the D is the C. So the 4C has to go first. And then anything with a C would have to come next. So the 10CD would have to go next. Then I'm going to drop in my 3D because the D is by itself. And then last but not least is my -6. So there is my polynomial. All right, let's do one more example of distributing our negative. And we've kind of talked about what the vertical looks like. I'm going to go ahead and distribute and do this one horizontally. And it doesn't make any difference to me which way you do it as long as you get there. So if I distribute my -1, that's always the first thing you start with is distribute. So -7n and -4n cubed, I'm going to drop down all of these other terms. And then I'm going to be combining like terms. Well, where's my largest one? This is my largest one. So I'm going to go ahead and combine these to start with and try to put them in order at the same time. So 13n cubed plus a -4, that's going to be 9n cubed. So now those are gone. Okay, so I have a squared, an n, and another n. So I know that my n squared is going to come next. So that's going to drop. And then last but not least, I have the 5n and the -7n. 5 plus -7 is a -2. And I'm done. And I want to look. 3, 2, and 1. It's in order, decreasing. I am finished. All right, see what you can do with your homework tonight. Reach out to us if you are struggling. Remember, do not save paper on this. Write them out. You're going to have to be submitting your work anyway. So do not save paper, distribute, combine the like terms so we can see what you're doing. Just because you're at home doesn't mean I don't get to look at your work. And let us know if you're stuck.